My name is David Ferris. I am a journalist who writes for a publication called EnergyWire in Washington, D.C. In the last year, there's been a surge in interest about energy storage and all the many things it can do for transportation and for the electric grid. And I'm excited to have a great panel to discuss those developments today. What our panelists are going to discuss is all the many ways that energy storage can help, for example, the electric grid, and incorporating renewable energy, allowing us to use more of it and to use it better, to allow us to make the entire grid more efficient and more resilient, more able to recover from the damage from superstorms caused by climate change, and also to advance electric transportation. Our panel to discuss these topics are Mikhail Koslov, Director of Innovations and Renewable Energy Sources at Rushydro; Dominique Fache, who is a member of the Board of Directors of the Sofia Antipolis Foundation; Edward Heindel, who is a scientist, inventor, and entrepreneur who's going to be telling us about his energy storage invention; Olga Prokofieva, who's a member of the Board of Directors of the Energy Group; and finally we have Keith Stevenson, who's Director of the Electrochemical Power Industry Center at Skoltech. So with no more ado, we'll start the conversation with you, Mikhail. Take it away.
Thank you. Thank you very much for the invitation, and thank you very much to give that opportunity. Well, anyway, I will speak in Russian, if you don't mind.
So, in my presentation, I would like to give you an overall picture of storage devices and tell you why this is, in our opinion, a very important trend, a very important area. So, if we would look at the way energy systems look like today, they are divided into generation, networks, or grid, and consumers. So, all elements of the systems are clearly defined and they do not interact. However, recently, all the components faced serious problems which have to do with storage systems. We will cover all of them. So regarding consumptions, we see a serious disbalance in the world, which has to do with energy resources. The first threshold. We also see serious imbalance and flow of energy from generating countries to countries facing a shortage of energy, and the same applies to raw materials. So at the global level, the power industry faces serious geographical imbalances. Also, there are considerable time imbalances. So in previous session, we were talking about renewable energy, and there was given a wonderful example from the last year, the situation which happened in Germany in one of summer sunny days, where the price was minus 100 euros per megawatt. That means power plants had to pay for their energy to go into the grid. Happily, it happened for only one day, but this is a situation which keeps reproducing itself. Also, regarding utilization of energy, I would like to show you an image. So you see the load of one heat unit in 2009, and at the right, the load on one generating unit in 2011, and that had to do with uncontrolled development of renewable energy, which was not accompanied by the correct development of storage, of energy storing system. And as a result, we saw a drop in the rating of power companies. So those are data from PricewaterhouseCoopers, which show credit rating of US companies. You see that there are no companies with AAA rating, and the number of companies with good positive ratings decreases. This is the example of US alone, but we also know that European power industry company in just a few years lost huge amounts in the overall company value. So in our opinion, these problems and other problems could be resolved, or the adverse effect could be reduced due to storage. As for consumers, storage system would improve reliability, quality, management of energy, and could be used in smart grid and smart house systems. The advantages are nearly the same for grids, so higher reliability, lower overflow, and less losses. For generation, again, it's high reliability, high quality, optimizing operation modes. And when we examine it all together, we realize that tomorrow power system would be quite different from the way it looks today. And this is the picture we came to nowadays. It's much more complicated, and the characteristic feature is that you don't have clear generators or consumers or grids, and you know that every end user can install a solar cell or a wind generator and become a generator. Grids are in all three roles, the same as generators. So this is the new trend in the energy system development we are moving to. And this is confirmed by the position of our company and all major power industry companies in the world. So you see that the energy storage systems are present at all stages, and of course this is one of the essential components of such a structure. So regarding the types of storage units, we separated them into two classes, from kilowatts to dozens megawatts, and from dozens megawatts to gigawatts. Electrochemical, lithium-ion technologies, I will not list them all. Cynetic storage units, and for larger storage systems we have compressed air energy storage, pneumatic accumulating systems, classical HPPs, and heat dynamic and cryogenic storage systems. Those are the systems which allow to cater for the power generating systems as such. A very exciting solution, in our opinion, are alternatives. And here we have a classical example of Iceland, where Iceland having excesses of energy, well, is being sold in aluminum. So it's been stored in aluminum, which is being sold to consumers. And another alternative is where Rushhydro works together with the Japanese partners. So energy is stored in hydrogen, and you see an image from Chiyoda, Japanese company, which invented a very exciting way of transporting hydrogen in a liquid which could be transported in normal atmospheric pressure. There is an alternative solution from Kawasaki, and Hydro developed a normal cryogenic solution for transporting liquefied hydrogen. But anyway, this is a system of transporting energy not as electricity but in another form. And there are some exotic options, also developments from Russia, US, Japan, on how to transfer energy as a laser beam or in some other exotic options. And as a conclusion to this part of presentation, I would like to say that storage of energy is an integral element of the energy system of the future. And one of consultancies said that in the nearest 10 years, the market of larger energy storing systems will grow by 20 times in the nearest future. And the last thing I would like to point out is that conclusions I listed in my presentation resulted from a discussion Global Sustainable Electricity Partnership had in Moscow. GSEP is an international association which includes Hydro as a representative of Russia, and a report was signed where all the companies expressed their concern and proved the need for developing flexible and adaptive energy storage systems. And energy storage is one of the integral elements. So that's about all. Thanks very much for your attention. I'm ready to answer your questions.
Thank you very much, Mikhail. Helpful. I'm going to turn it over next to Dominique.
Sorry, there is one question. I am from Moscow Energy Institute, and you said that one of the possible material energy storage and accumulator could be hydrogen. But would it be possible to use hydrocarbons as not just hydrogen, because hydrogen is not so convenient for storage and transfer because it's flammable and explosive. Yeah. So if we take hydrocarbon, well, there are no limitations on how you can transport and store energy. You are correct that in its classical form, hydrogen is not so easy to store and transport, but there are solutions, and I told you about one of them, Japanese developments, where hydrogen is bonded to another chemical element and becomes liquid, very similar to liquid hydrocarbons, and very close to bitumen, which could be transported via existing infrastructure, pipe racks and wagons, because hydrocarbons are a move towards petrochemistry. To that, I would like to give you the example of Japan.
Questions at the end of the session. We can get back to that later. Okay. Mr. Fash?
I got the ball. Yeah? Я буду по-русски.
Okay, I will talk in Russian, and that will be brief. First of all, I would like to repeat what I said yesterday about technologies of the future. Technologies of the future are not subject to any sanctions. I think you understand what I mean, including that technology. So that technology is really something we need. And you know that we are in an turbulent zone in our power industry. In the 20th century, we lived according to certain criteria, following a certain pattern, also in the power industry. And now, after a number of accidents, Fukushima, we are now in the turbulence zone, and everybody feels that the pattern we used to live in line with is being changed due to a number of factors. And there is a blind alley. Everybody understands that for power industry, storage is a key issue. Take a look at what's going on in Germany, what's happening to the grids. Take a look at what's the case with the renewables in Spain. In France, I have to pay 15% more to the factory to compensate for the energy which is needed, but which is non-existent. This is an absurdity, and everybody understands that the question of storage becomes a key issue to enable a new model, including a business model. So there is Nobel Prize. I would give 5 Nobel Prizes to the team which would resolve this problem. Well, I would not comment on what Mikhail said. He was correct in his conclusions, but I would like you, well, you probably know ITER project, a well-known one. Well, it's carried out in our country, in Cadarache of France. A lot of concrete is being used. Well, a lot of corruption around the construction. So it used to be 10, then 12, then 16 billions. And as Riva showed, we will probably reach to 20 billion euros. But 20 billion euros is the shortage in the French social welfare system. And we are spending huge money, and we include a consortium of Europe, France, Russia, China, the United States. So everybody came to a consensus in order. It was a consensus on financing a blind alley. In 10 or 15 years, we will take a look at the superflex of France, and we would realize that the cost was 20 billion euros. So probably part of the money could be used in investment, in developing energy in the world. 2 billion people in the world have no access to sources of energy. So this is a key issue that requires some financial efforts and agreement. But we are following the path which has no prospects. And this is an evidence to the fact that we need a general solution, and understanding that we can invest at least part of money in it overall. And we see some developments in the United States, but so far I don't see any global solution, but it is a must.
Thank you, Dominique. Next, I'd like to hear from Olga, who can tell us about what her company, the Energy Group, is doing, and also perhaps give us a look at what the state of energy storage is or isn't in Russia today.
Thank you very much. I will also speak in Russian. So, я бы хотела, вот здесь уже подняли интересную достаточно.
the topic was brought about, which is very interesting in terms of the developing of the energy storage market, about key importance of this topic globally. I'd like to narrow the focus on the Russian market and Russian developments which are being done currently. We've been dealing with developments in the area of energy storage for 6 years. We've been involved in their implementation in Russia, and we have to stress here a problem which unfortunately is connected to the applicable legislation of Russia, which does not imply and is not suitable for implementation of these developments and innovation due to different reasons. First of all, the problem is coming from the regional level, because on the regional level there is lack of understanding of different technologies and why should we store energy, why should we accumulate energy, and how it will influence the economics. On the federal level, we together with the Ministry of Energy develop different programs for further expansion of energy storage market and to develop innovation topics and to support Russian scientists in this area. But again, unfortunately, it moves very slowly. A separate aspect that I wanted to highlight, storages play a very important role in the energy industry development in the country and also for the territories of Far East and Siberia. For instance, it is very pressing now the issue of development of Far East federal districts and to build up industrial parks there. The task is to build up a high-quality energy grid there, and our colleagues from Rushydro and Minenergo do a lot in this area. And the development of these solutions will be very important there. And the support for innovations in Russia also, unfortunately, is not always done properly, because many private companies which were developed actively before crisis, after 2008, went out of the business due to the lack of funding. So we need, on the federal level and on the level of key ministries, to develop and to support this direction and to incentivize Russian innovations and their implementation in the Russian market. In general, I wanted to turn our discussion in this aspect. Thank you.
Next, we'll be hearing from Edward to hear about. No, he does have a. Oh.
Yeah, welcome.
He has a solution for energy storage he would like to share with us.
Yeah, so I talk for this Nobel Prize. Okay, let's look into this topic that is not really understood to most of the people, is that energy produced by photovoltaics is an extremely fast-growing trend on the global scale. That means within the last 20 years we had 100 times more solar energy, and different countries are really rushing into that. Especially the red line here is China, and the global trend is that within a growth rate of 25% we will run into a global sustainable energy development by photovoltaics in year 2030. And the reason is now today the Svensson law that tells us that doubling the production of photovoltaics reduces the price of 20%. That means the price is constantly going down, and more countries are economically able to produce solar energy without any subsidies of the government. So this, again, today we have only 0.5% of photovoltaics, and 20 years ago it was only 0.03. But what is going on within the future will be 50% in 28. That is quite near. It's only 15 years ago. So that's a global thing, but the big problem on the globe is that we have no storage to this large amount of energy. What to do? Now, there is an interesting thing. If you look into a traditional way to produce solar power, you have cut the peak during the day, and then you don't need storage. But when you build up more photovoltaics, you end up in a way that you produce more energy during the day than you need at all, and so you can shift that into the night. Doing this is not easy because you need storage, and the storage capacity is quite high in Germany, but it only is sufficient for half an hour, so that doesn't work. Now, when we build storage, and that answers some questions we already had, is what is the big point is we need a very cheap storage, we need high efficiency, and we need a small footprint. We don't want to impact the environment. So batteries are quite high in price and have quite a big footprint because you have to dig out all the metals. Power to gas, that was the question from the Moscow University. The problem is the efficiency. This cycles only with 25%. That's too low for a big business. Hydropower is quite perfect, but you need a lot of land area. My idea is quite simple. What we want to build is we cut out a large amount of rock in using mining technologies, drilling down to this area, and then if we can cut it, then we are able to move with mass of rock by hydraulic means. That is, the technology is used here is standard mining technology. We did a lot of studies how to cut it out. It's quite not impossible. I also in January gave a talk to this in Moscow. Then we seal the system, and so we can store the energy in a mass of rock by pumping down water. And its amazing thing is that we can store an awful lot of energy. And to understand this, now comes a little bit tricky situation. If we have a design like that, the energy that we can store is proportional to the fourth power of the radius. That means we can store very much energy, and the building cost is very low because it drops down, or it increases only with r squared. That means we can build energy storage just at an arbitrary low price. And to give it in a very simple word, what happens here, if you don't like the math, if you double the radius, the price goes down to a quarter. And that is the key. You can build now storage at a price level that is undoubtedly cheaper than any other thing. Now, do rocks like a large scale? Yes, they do. Sometimes we find them in nature. Is sealing a big topic? Yes, we have to go into that, but it is done now. We have worked out that it really works, and we did study on that. How to operate a system like that? Very simple. If you have more energy in the grid than you need, then your energy goes into this pumping system. The pumping system puts pressurized water below there, and it's exactly the same pressure that we use in pumped hydro systems. It's not a new way to do it. That is very interesting. So you don't need new machinery. You need the standard equipment you already have in hydro systems, and then if you release the energy during night, you have the same release mechanism. So the simple model is buy cheap power during the day, wait till night, and sell the expensive power. One system is 250 meters, quite not too large, is worth 60 million. One day, every day, the electricity that is stored in the system is worth 16 million. So you have a big business, low price per kilowatt hour, high efficiency, small footprint. And so we can have a renewable energy if we are able to store the energy. Thank you. That was a short presentation.
Thank you, Edward. That's a very inspiring and interesting approach to energy storage. Our final speaker is going to be Keith Stevenson, who's director of the Electrical Chemical Power Group at Skoltech. He just started recently, and his group is looking to both build knowledge in energy storage and also to commercialize it. Take it away, Keith.
Can I get the clicker? Well, I'm going to speak in English because my Russian is not so good. And I hope to learn and master the language a little better than I have right now. So, can you hear me? Okay. So I've just started at a new university. It's a new model that's funded by Skolkovo Foundation. The idea is to really integrate research and education and innovate in a new graduate level university. And so there's several different clusters of focus. One is involving several centers that have to deal with the generation, utilization, and development of new energy technologies. And so the footprint of this is that Skoltech is accelerating growth. Roughly, they want to hire 200 faculty with roughly 300 postdocs and educate on average about 1,200 graduate students by 2020. And they're going to build this all on a new campus just south of Moscow, known as the Skolkovo region. In particular, for the center that I'm the director of, involves two partners, one a group at Moscow State in chemistry and physics, and another well-known international group at MIT. And currently, as director of the Skolkovo Tech part, I'm hiring faculty in this key area and addressing needs that are really related to energy storage as chemical fuels, and then convert those chemical fuels to electrical energy when you need them. So the point was brought up about this supply versus demand, and typically if you want to put renewables onto the grid, you need to be able to store that energy when it's generated and then utilize it when it's required. So for instance, wind blows at night, sun shines during the day, so if you use solar or windmills, you typically need to couple that with a storage device that matches the size of that particular generation. One windmill's on the order of one megawatt, 5 megawatts or so. And in Texas, for instance, we have a lot of wind, but we can't put it on the grid because the grid is too antiquated. And so there's a lot of issues with how you actually develop storage solutions for that type of renewable source. The other part of this is that in terms of a power industry, people want to be able to develop mechanisms so that they can forecast and sell energy back at different points in time. And also the consumers want to save energy. They want to be able to adopt things in their home so that they can utilize the energy more efficiency. And so this then ties into kind of what's depicted at the bottom here. There's kind of these four different areas that are outlined in terms of very specific types of energy storage. The most common that I think people know now is the reversible lithium-ion systems. This works really well for portable electronics, but it doesn't scale to larger footprint systems. And it primarily has to do with the fact that it's lithium-based, and the materials that we use in there are relatively heavy and costly. But there's strategies to go to things like sodium ion, which are much more cheaper, it's more earth abundant, that could really solve especially storage for grid type applications. Of course, we want to worry about transportation, all electric vehicles. There's some ideas there where that could actually play into smart storage, where you charge the car at night, but then you drive it to work, and then you actually sell energy back to the grid when your car's out in the parking lot. And then from a chemical storage standpoint, these are typically evolve around fuel and electrolysis cells or flow batteries. And all of these mechanisms in these two areas, they have to do with storing energy as chemical fuel. So hydrogen economy, obviously you oxidize hydrogen to make hydronium ions. You reduce oxygen from the air, and that's a very efficient device. Unfortunately, it's very costly to do that. It requires noble metals, but we'd like to move to more cost-effective solutions there. It was brought up about the idea that you could use other hydrocarbons, and so part of this work involves what's known as solid oxide fuel cells. These are the direct conversion of things like methane or other hydrocarbons to generate electrical energy. They work with a different set of schemes than the hydrogen-based fuel cells. And then the last part really has to do with liquids that actually have electrochemical properties that are stored in large tanks. And so this is a way to actually convert, again, stored chemical energy into electrical energy that could be very dirt cheap for large-scale grid and power supply type things, like equivalent to pump hydro. Right now it's way too costly to do this kind of thing on a large scale. So last, I just want to kind of leave off with the other important component to this from my perspective. It was mentioned about the innovation in Russia to be able to do this in-house. We can't just import a lot of these technologies that now are starting to be developed. They have to be, Russia has to have command and also be able to implement some of their own solutions. And so part of this Skoltech model is to really develop the future people that will do this in Russia.
Thank you, Keith. We'll get to questions from the audience in a few minutes, but I wanted to tee off something that you said last. And since this is an innovators conference, and I think we have people in the audience who are seeking seeking opportunities, what would you advise people thinking about pursuing energy storage in Russia to think? What should they do? What strategies should they have? What advice do you have for them? I'll open it up to anyone.
Well, I guess I can start. One is to really move away for more grid level storage, move away from anything lithium ion based, because that's really expensive. And maybe you could do sodium ion, and in particular sodium ion in aqueous solution or maybe in non-aqueous solutions could be something that really can scale. And it's because really that we have a very abundant amount of sodium. You could move to other things like magnesium, which is doubly valent. It's, it's a doubly charged cation, and then that doubles the energy density. And so those types of strategies are being pursued. Unfortunately, we're really limited from a material standpoint. We just don't have things to store energy in that form. The available electrodes that we use in these devices don't really exist, haven't really been discovered. And then also in redox flow, you could think about maybe combining storing carbon dioxide, for instance, but then converting it when you actually want to burn it as electrical energy. So rather than develop, say for instance, a metal air system, you could develop something like metal CO2. And that would then be both a storage medium, but also an energy conversion scheme. Of course, again, we're really limited in our knowledge about how to do that and what types of materials that it would take in order to make that a realization.
Yeah, the big point with chemical storage is that they degenerate over a long time. So if you want to go really in grid scale, you have to build systems that are working over not over centuries, but over tens of years. And the second thing is, on the global scale, 99% of all storage systems are hydro-pumped systems. So we are well understand these systems, and I think for cars it is a real great idea to have perfect magnesium, lithium, or whatever chemical type it is, because they have to be very light. But on a grid scale, they have to be very efficient, and they have to be very large scale and long living. So some research should go into that, and especially in Russia, it's a country with a big experience in mining industry, so it makes sense to go in developing real new types, like my concept where you dig down and then you can store it in the mine in some way.
Anyone else? Then another question, I'm wondering, since energy storage is such a flexible thing, it's something that could be used, like a lot of our speakers said, to support the spread of renewable energy. It can also be used to improve the performance of the grid, to make it more efficient for to power cars. And in the Russian context, what's the most useful thing? What is going to get what fulfills Russia's needs the best?
Basically, I would say that okay, I will switch to Russian back. So, я думаю, что
I think that all mentioned options are suitable except for so far electric vehicles, because for today they're not developed, but they will be developed. But anything else, both energy storage to reduce peaks, to reduce overflows, and to reduce cost, this is all valid and relevant, especially taking into account such a big geographic spread, geographic distance of grids, and the differences in the generation and consumption centers. The storage system would allow to solve these tasks partially, at least. I'd like to highlight one thing here, that the storage cannot exist as it is on its own. It has to be a comprehensive system, and I'd like to cite two examples here.
к цене на мегаватт. Хочу напомнить, что мегаватт во Франции стоит 55 евро, а в Германии 2 раза больше. Я не говорю о бытовых ценах, я говорю о оптовых ценах. Мегаватт. Час, да. Ну, у нас из создавшейся ситуации, которые, вот вы знаете, что у нас 78% атомной энергетики, поэтому такая дешевая цена. Но цена вот входит и имеет определенное влияние на бизнес-модель вот здесь. И я хочу тоже подчеркнуть важность другого момента, который сегодня существует.
And I would like to emphasize another point, which requires a certain level of IT, smoothing the energy, because smoothing is using virtual energy which is not being produced. So we need to review the entire problem as a chain, where the price is important and where smoothing is again important, and the consumption, the forecasts for energy consumption are not clear. There is a big difference between consumption in China and India and in our society, where due to lower intensity, the consumption is almost flat. So hence, we have a problem with restoring nuclear power plants in France today. So those questions, those points are in line with the general picture, where other factors are equally important.
To the audience to ask any questions you have of our panel.
Alexander from Rusnano, do you see a problem for Russia in the lack of certification? Yeah, because many solutions are new for the innovative energy. I would like to rephrase this question. This is a very correct question. It's not a question of certification, but it's rather about the rules of the market. Both in Europe and in Russia it's even more noticeable. Energy storage systems are not economically viable, and it's not possible to change the situation. And it's not because they are expensive, but it's because of the existing laws of the market. And this is what we have to work with. As we said, we need to change the motivation system. We need to balance the services in the market. Certification is required, but it's secondary in my vision. I think that Mikhail wanted to say that it's not possible under the system operators that exist. So when system operators are reformed, then the power industry of Russia could be reformed. Dear colleagues, I would like to say a couple of more words. So I'm from Kurchatov Institute, and I remember academician Melechov, who offered a nuclear reactor with partially the decomposition cycle. So it's simpler than ITER's project, but it's safer compared to nuclear power plants, because if you take into the account the measures to prevent reactor from the damage, yeah, so the average cost could be of about $5 million US. When we were talking about storage, there are a number of technologies like liquid nitrogen, and such stations are being developed in the United Kingdom and also in Russia. Vladimir Romanovsky offered a liquid nitrogen accumulator for a number of time, and the performance rate is quite high, of 60%. So I would not like to restrict ourselves to only technologies which were described. And my question is to Eduard. You didn't specify how much kilowatts per hour are stored in a unit of volume, or maybe I didn't hear the answer.
Question about the, you are right, I didn't answer the question how much kilowatt hours we can store. In this first prototype we will now build, it is 1 gigawatt hour, and the radius of the system is 75 meters. So that gives you some impression. If you double the radius from 75 to 150 meter, you are in the range of 60 gigawatt hours. So that is the area we are working in the moment, and you can go up to 250 meters. Our computer simulations show it is possible to do that. Then are we in the range of 120 gigawatt hours. Storage capacity. How much turbines you connect to this system depends on the requirements. If you take solar systems, you may have a daily cycle. If you are working with wind energy systems, you usually have something like a weekly cycle, so it reduces the amount of converters.
What about the physical storage and transfer devices you use in your conditions? Physical energy storage devices, what type are currently in use?
Currently 99% of the storage in Germany is by pumped hydro. That means we pump water up to some hills in a large basin, and the capacity is 40 gigawatt hours complete capacity, and the complete grid connectivity to the systems is about 7 gigawatt power. So that is the situation today. We have learned in Germany that due to this solar, the first thing that happens is you reduce the storage capacity because it isn't longer needed. But then if you go further into solar, then you again need the storage capacity. But there is some interesting change, because thus the daily peak is cut it, and then you get this overload.
Is my understanding correct that the physical media to store energy is water?
Yes, you're right. Today it is water and using gravity, and in my system it is rock mass and using water as a hydraulic medium.
As for the rocks, the rock will move as you showed on your animation, right?
It looks as in the animation. The rock is moving about the a height like 75 meters, and this rock itself is very heavy in the range of some million tons of mass, and so this movement and this stores the energy. So the movement is induced by the pumped hydro system that pumps water beneath the rock, and by hydraulic forces it's going up. The pressure itself is quite interesting low, it's about 30 bars. The reason is the scale of this hydraulic element is very large, so you don't need a big pressure, and the pressure is exactly the same range that we use today in our pumped hydro systems in the mountains. It's about usually 400 meters, just the same type of pumps, the same type of turbines, and the cycle efficiency is 80%. That is very interesting because we know the cycle efficiency due to the many pumped hydro systems.
Сколько гигаватт тратится на
So how many gigawatts are spent per pump? Yeah, because you know here we are working with a rock mass.
The session, so we can move on to some other questions. Can we take another question from the audience?
У меня такой вопрос.
I've got a question. We are discussing very important things connected to macro energetics, but there is micro energetics, which is very important for a number of systems which are commonly used now in medicine, like power supply sources that could be used for dozens of years, photovoltaic based on nickel. And yeah, what could you say on these types of power sources? For instance, our colleagues from Skolkovo.
Ignore, you know, the scale of the energy and the size of the device which you're trying to power.
Could you speak louder because even we don't hear you.
Yeah, I'm sorry. So this is a very good question because oftentimes when we talk about renewables and grids, those are very large-scale systems. But there's also strategies for doing both energy recovery from small distributed systems, like for instance in your shoes on your body, and transducing mechanical actuation into storage mediums. Right, and so this is really going to, I think, becoming driven more from the consumer and the convenience markets. You know, you want to be able to have self-diagnostic monitoring, for instance, wearable fabrics that also store and harvest energy, and then charge your phone. And so these would be, of course, a different set of strategies. But in most of those, it's really concerns with the cost of the storage materials, and also how they get integrated into a functional form that then can very easily reversibly convert some type of mechanical or electrical, optical type energy into electrical energy and then back and forth. And we don't really know how to do this as well. I think there's going to be a lot of developments in the area of photonics materials, quantum-based photonic materials that can really efficiently convert, for instance, light energy into stored energy. And this is a big growth in the world right now. A lot of people are moving towards this. And also in flexible energy storage devices, for instance, the skin of a car or the skin of some type of component that houses it. It's just not a physical structure anymore. It's actually a functional structure. And so here, these will be much farther out there type of ideas, but they're very important.
Did anyone else on the panel want to address that question?
Отвечая на ваш вопрос, в общем-то, по...
Answering your question on power units based on nickel, as earlier this year, together with Manogor, we started some research. I think that in 3 years we will see the first result on how this research could be implemented.
I just wanted to add, since it wasn't introduced.
представиться, позвольте, Алексей Данилин.
I am Alexei Danilenko from Nova company. We are integrating semiconductor production, complex semiconductors with producers of nickel 52 to get solar cells. And I'm really happy that the process is underway and that the result is likely to be promising for, it would be a nice solution for our health care industry, and it would get wonderful support in the form of that technology.
The gentleman on the end is Anton Chaskin. He is the division head of the Department of Science and Technologies at the Ministry of Education and Science for the Russian Federation. He's here as an expert rather than as a panelist to chip in knowledge when needed. I'd like to ask a question about the existing knowledge for energy storage in Russia. Obviously, Russia has a great depth of scientific knowledge in a lot of areas, and one of them is energy storage. Yet, the country is absent from the conversation about technology and where it's headed. And I'm wondering if any of our panelists could share what you think the particular strengths are of Russia when it comes to energy storage.
I don't see any particular strength because they are all equally strong. And I don't think that on this side of inventing energy storage systems, Russia is very different. But in our practice, in our experience, we see Russian solutions on energy storage in all areas, in small areas in kilowatts and hundreds of kilowatts, in smaller capacity systems and in larger systems, from hydro pump plants. We also have Russian solutions on pneumatic, on air compression stations, and innovative companies offering thermodynamic storage systems. And this is Russian engineering schools and Russian companies. And in my vision, the entire range is where Russia is competitive in innovations and in engineering solutions. Thank you.
Keith, did I cut someone off there? Keith, I was interested in your thoughts on this, since you are in the position of working both with Russian engineers and scientists and American ones.
Yeah, so of course I'm kind of new to Russia and understanding some of the issues, but one of the things that I was really attracted to about the Skoltech model is that a lot of the local talent and knowledge, people are very smart, but what they really want to do is they're hungry to develop something new, right? And they want to actually become the person who owns the company and to innovate with that. And so around this Skoltech model, they have a lot of focus on prototyping, rapid prototyping, trying to show proof of concept, and then attracting local companies and industries that might be interested in some of the newer ideas. And so the younger students, they seem really motivated to do this. And that's different. Also in the States, we do everything kind of very formal in terms of how people get educated, but we don't really integrate the conception of an idea and the basic understanding into a real product. And scientists and engineers in particular, they're really trained in kind of the formal parts, science, math, and engineering concepts. But then when you want to try to transition a fundamental discovery into an innovative solution, you need to really kind of change the model of how to do that and integrate it. And this is something that Skoltech is trying to do. Now, of course, they've partnered with MIT because they've done this historically very well. They really can take something that's found in the lab and transition it and start companies from this kind of a model. And they have mechanisms really to provide both the IP expertise and also the business models to really make a chance of success. So this is attractive.
Do we have another question from the audience?
We'd like to look at the vision, how the special costs of storage would reduce going forward. Will it be the drop in percent, dozens of percent, or by order of magnitude? What is your opinion?
The first point is, if you have different types of storage system, very short period, medium period like batteries, and long period, the batteries will drop in the same way as it happened with solar cells. So doubling the market will always drop it about 20%. So if we see the rollout of electromobile cars like Tesla and these companies, we will see a real sharp drop in the next years of about a factor of 2 or even more. On the other hand, as I introduced with my system, the price is depending on the size. So size is really a big issue. If you build something small, you sometimes don't really earn the effect of scale. If you build it large, you will have a big effect on the scaling. So our system, we calculate usually about €100 per kilowatt hour capacity. Today, if you buy a lithium battery itself without the electronics, you are about €500 per kilowatt hour. Yes, that's the region, about a factor of 5. And if you buy a complete advanced system for at home in Germany, you buy about €2,000 per kilowatt hour.
Я бы добавил одно.
I would add one comment here that along with the strong reduction of energy storage, we will see the growth of cost of energy. So the efficiency of storage will be increased due to 2 factors. And it is inevitable, and in my opinion, it will be a serious trend expressed not in just a single percent, but in the orders of magnitude.
How Russia needs technology that's not subject to sanctions. And I'm wondering if sanctions persist, I'm wondering if you and the other panelists could give your opinion on what the effect would be on the future of energy storage in Russia. Do the sanctions chill the investment atmosphere to the point where it's an industry that won't happen? Or will it create a need for forms of energy that, as you said, aren't subject to sanctions?
Я отвечу на вопрос.
I will answer the question in English. I'd like to add also to your question and to return to the question. And Mikhail is right. The general business model has an impact on the price. And I'd like to highlight this, that in Russia we see the investment of separate groups of industrialists in separated standalone energy systems. They are not willing to connect to the general system. Then the question of storage is absolutely different. And we really feel that, and you know about it. Now to the second question.
Today about a completely different issue, which basically had to do with one of my previous main companies, Schlumberger. I remember a year ago I was talking to one of the big guys of the Russian oil and gas business. And he asked me about the story of Schlumberger. So I told him the story of the brother, Conrad Marcel Schlumberger. They came to Russia in the 20s. They invented this new geophysic service company. Basically, never sell equipment, sell service. Big lesson. And I told him that basically today you should take care about not putting your eggs in the same basket. And by stimulating the creation in Russia, not of a big state, Rosgeologia, but of young company. Basically, people have the knowledge. There is the resource. MFTI, Baumann, Fisterk. There is a lot of place, so basically there are the right people to do that. And to give them the chance, first of all, to stay in the country, because your good guys, they're gone. They are in Houston, they are in California, in Manchester. And secondly, you should have your own resource. I didn't think that I'm going to be right so quickly. That's a question for Russia to face the new technology they need for Bajenov suite, for Arctic, for the new technology needed for oil and gas. They have to invest in this and not to rely on Baker Hughes or Halliburton or Schlumberger, my former company. And that's also something in the storage. I mean, we can apply that for different technology. They should make an effort, but the right one. And I don't think it was in the press in the last 2 days that putting together 11 blind people make a football team.
Добавлю, опять же, в развитие того, что я сказал перед этим.
I will add one thing answering to your question in terms of technologies and technical solutions. On my opinion, Russia is quite self-sufficient for the technology of production. There are lots of things in place there. The majority of technologies are in place, but I do not see any technical solutions which would be exclusive in some country and which would have some effect as relates sanctions. What we lack here, it can be organized here in Russia. The production can be organized or bought even under these hard conditions abroad. I don't see any problems here, maybe except some change in the cost of the specific solution. Thank you.
Если нет пока другого вопроса.
If there are no other questions, I'd like to come back to the answer to the question which we discussed in the beginning from May students that we interrupted. I'd like to add a few words about the Japanese policy towards hydrogen. 2 weeks ago, there was a very interesting conference in Japan where the Prime Minister had a speech, Mr. Abe, who said that starting from the next year, and Japan has 20 years long hydrogen energy within which they work with Rusk Hydro and other companies, but this program implies a very multifunctional development, and this is a nice example how the state should develop and foster the development and solutions also in the area of energy storage. Starting from next year, fuel cell-based cars start to be sold in Japan, and the government took off 26 restrictions which were applicable In Japan, 26 acts were cancelled, which were preventing from implementation of this program. All the ministry of the government ministers will drive these fuel cell cars, and they also provide $20,000 discount for buying these cars. And this is only the first step going forward in the way of development of this hydrogen-based energy. And this is an example of the interest in the country, interest for the future technologies and future development. Unfortunately, there are only a few countries which have such a comprehensive approach, but this approach is very nice and is already implemented.
Я преподаватель МЭИ и научный сотрудник.
My question was not just from students, but very specific. In MEI, we have certain programs of storage of energy, and if Rus Hydro really puts these tasks, how such cooperation is possible? To what extent could it be possible? How can we organize it? Between the Institute and the Rus Hydro, the cooperation is not only possible, it is already in place. Moreover, we have a special chair in MEI, which is supported by Rus Hydro, which is headed by the employee of the company. This is a hydro energy and renewable energy chair, and the partnership in the institute is really developing. There's no problem. If your area is still lacking the link with Rus Hydro, there is a bunch of ways how to organize it. We always welcome that. So with pleasure, thank you. I'll give you his number.
I want to add to this political issue, because it was very interesting to say that in Japan they stopped a lot of hurdles to use special technology. That is a big point, especially in Germany. The renewable power industry, and then in this following the storage technology, was really strengthened by reducing laws about who is allowed to bring energy to the grid. We are still not in a perfect situation, but with the first thing we break up the big energy providers into smaller companies, then we cut the grid from the producer. That means that there's a different company who owns the grid and who owns the power station, and then every household is allowed to produce power, or every small company. So today in Germany we have 2 million different producer of energy, 2 million households, small windmills, whatever type. And this is a very big strengthening of new technologies, because then we have a market and the people drop at the places where interesting thing happens and where it is possible to earn some money. And so it is, we are not perfect in Germany, we are still big influenced by the very large power organizations, companies, but it helped really a lot to change it, and today we have about 28% of renewable energy within a growth from just 3% within 10 years. That was a big effect on that.
I'd like to add one thing to the question raised by Edward. Yes, it is really important, and it's also a matter of a big dispute in Europe. Which player of the market holds the generation system? Are these generators or grid companies? And the answer to this question is so far absent. For instance, in Italy, in France, there is a big dispute about it, and the result of these decision-making will have a strong impact on the interest of different market players in terms of promoting this topic. And we as generators, for instance, think that storage system should be owned by generators. Utility companies think that that's a big challenge here, and they argue that. Yes, Michael is ready here. This is a systematic problem. We have to look in a comprehensive way at all this. I should say that France adopted yesterday a law on the transition of energy. I don't know exactly, but there's nothing special about the area of storage. I don't remember that it will be something. There are other areas, and there is a majority in Parliament to support this law. I also would like to say that so far I don't know what will be the agenda in the Paris conference in December next year, and whether it will be in general, because there are still big problems. I cannot say that still in Germany there are renewables, and I will not mention prices. Prices are quite high, and very many families in Germany are on the threshold of poverty versus France, of course. And they have 45% of coal generation. We shouldn't forget that.
It is absolutely true. Introducing the solar at the beginning was really subsidized by the state. Then they continually have gone out of the subsidization. But the central point is really to allow everyone who has a way to generate power that he's allowed to sell that to the grid. The second thing is about storage. Who is owner of the storage systems? At that point, Germany is not very good. It is at the producer of the energy and not at the grid side or not at some different side. We are now discussing what is the right place for the storage, because it's a little bit tricky to make that. And you are right, the coal is a big problem in Germany. We have gone into this ignited coal that produces a lot of CO2. That is quite not nice. The reason was not solar energy. The reason was cutting down the nuclear power stations in Germany. That was a very special effect due to Fukushima and our political situation in Germany. It is really unique.
As Edward said, part of the impetus to accelerate energy storage systems in Germany is the spread of distributed solar. That's certainly the case in the United States as well. And since you, Mikhail, said that the expertise exists to do this within Russia, where do you think the impetus comes from to catalyze energy storage in this country?
Problems which hinders us from developing?
No, I was actually wondering more whether the solution will come down from above, from the government, or whether you think that it will come up from below, like it has in other countries.
На мой взгляд,
in my vision, if we separate energy storage systems into medium-sized and smaller, well, let's put it aside. As for medium-sized system for dozens or hundreds kilowatts, I think that they will be regulated by standard market mechanism. There is some offer which is limited due to high price and little demand, but over time price for energy will change, and the cost of energy storage will go down, and they are likely to be developed from the far east of Russia, because in the Far East you have a lot of isolated, contained systems. In the Far East we have a lot of places with very high price per electricity due to the need to use diesel oil, and you have a lot of places where all types of economy can be efficient, and there we can use it, and it will start moving from there into the European part of Russia. And as for systematic accumulators like pump storage systems. They will not develop any faster than they do today, in the absence of any public support. But even rules of the market would be enough. There is development, so Rushydro are building a number of new modern type power plants. The process is going on.
Several members of our panel are from abroad, from Europe and from the US. I'm wondering whether you gentlemen have any advice for Russians on how to proceed. Given that the market in the US with you, Keith, is further along, and given that it's further along in Germany, what should Russians keep in mind as they develop their energy storage industry?
So this is a good question. I don't know if I'd phrase it in terms of advice. You know, my advice is free, so take it for what it's worth. But I would say one thing that should be pointed out about when you have, much like in Russia and the United States, they have large centralized power stations based on coal and hydro and these sorts of things. And the issue with providing incentive to become more decentralized or distributed is really changes in terms of how you utilize that energy. And for instance, when you build a centralized power plant, what you need to know is the capacity. And then you want to try to be able to generate the energy based on the capacity and the demand. And those are things that, having one owner of that, it's somewhat easy to plan for. But if you start to make it more distributed, and you have these different partners that maybe own a certain part of it, the incentive really comes from the fact that you have increased energy reliability. You can deliver the demand on a more reliable basis, and you also, in a distributed system, you have more energy security in a sense, and less loss, catastrophic type loss. If for instance, the power plant blows up, or you have a catastrophic event like they had in Japan. So those two things, I think, are important to consider in this discussion. That it's not just we have a lot of energy, we can still do what we've done. We need to really think about how we're going to utilize energy in the future and how it's going to be distributed based on when it's demanded. And that's true on just about any scale of energy storage device, because you have different applications. The time point of the delivery of that energy really matters, which we call power, versus total energy density, which is basically how long you have to use it. And those are very complicated types of forecasting that you need to do. And so you need to be able to understand the fundamental limitations and the challenges of what particular storage solution you might have, but also how that might provide a very specific solution in one area, but not necessarily in another. And so these are things that people need to be involved in across many different levels to really help come up with the best strategy going forward.
Во-первых, не хотел.
Firstly, I would not like the situation we had in Europe, especially in Spain or in Italy, would repeat itself regarding renewable sources of energy. For renewable sources of energy, you need continuous support, because we started with big subsidies, like when they were 0.5%, but after a certain level, Spain rejected it, and there were indirect subventions to Chinese production of solar cells. So if you have some sort of support, you need to think on how to avoid those things. Regarding Russia, I've been working here for 23 years in the power industry, and I was head of RKK5 in the for 5 years. I was on the board of the market, And as far as I can understand, there are no rules of the game. There is no model of the market. And the capacity changes every year. And we have the board of the market, but we don't have the market. And this is a problem. And I don't know where things are going today. So I would prefer to have some progress in the reform which was started by Chubais some 8 years ago. But I believe the reform stopped and we don't know where things are going. And indeed, it's either the free market or the full control of the state. It's up to you to decide. But I have some serious questions here and now.
Edward.
Yeah. So I think Russia is one of the countries in the world owning most of the stored energy that is thinkable, because you own oil and gas, and that is stored energy. So don't waste this energy for low prices inside your country or wherever. So one idea is really use the price of the market for the stored energy, and then you'll see if there is something else competitive with it, for example wind or solar or other storage technologies. And so I have learned it from Saudi Arabia. They now switch to PV because they say, we sell the expensive oil and we save it in our own market because we can produce it much cheaper with, in this case of course, solar, than to use it in a diesel generator. And this is a very interesting point. And so I think it is useful to rethink the concept sometimes, because you own it, you have the energy, but it might be a good advice for the future to keep it as a perfect storage and to give it only away for special prices.
Thank you very much, Edward, for a concluding thought. I'd like to thank our panel for a very interesting, stimulating conversation about energy storage, and for the audience for contributing their questions. That concludes our session. Thank you all very much for coming.